Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by Professor Mary Helen Armour, actually recurring guest on York Universe. We have all kinds of great things planned for you tonight, but first I'd like to tell you that we are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at about 2 a.m. UT if that's more your speed. York Universe works in concert with our online public viewing program run by the amazing Observatory team on the YouTube channel. So, obviously, if you're here on YouTube watching this live, you will be seeing the online public viewing images run by our crew. If you'd like to find out more about our shows or listen to past episode recordings, you can always find out all of our schedules and all of our archives at yorku.ca/science/observatory. To navigate to OPV, just follow the links to online public viewing, OPV, or click on any link that says YouTube, and it'll take you to our channel for our regular Monday night show. All right, everyone. Well, it is great to be back on this Monday. If you do find that you are full of questions, you can always email us at observe@yorku.ca or ask your questions live in the chat as the show goes on tonight. If you're looking for us on social media, just an FYI, we are on Twitter at York Observatory, Instagram at York U Observatory, and Facebook at Allan Carswell Obs. All of our programs are free, but if you'd like to make a donation or buy some really cool astronomy swag, you can see our website at that same link from before, yorku.ca/science/observatory. Our crew is monitoring the chat room, excuse me, and posting content. The current weather is too cloudy to open at the moment, so I'm going to just take a little moment to remind everybody about our guest for tonight. In case you missed her previous episode, Professor Mary Helen Armour is a faculty at York University. She teaches a number of science courses in the Natural Science Division. Her background is both astronomy and earth sciences. She has an interest in a range of astronomy topics, and you will have seen her on the observatory website in the Astronomer in Residence program. That's right, AIR 2023. We might even see her back for 2024 as well. And she's got a recorded YouTube presentation specifically about her geology talks, impact structures. So, Mary, it's great to have you back on. So, how's the weather where you are?
Uh, Cloudy. We're
Yes,
having snow
cloudy.
during the day today. A couple of nights ago, we had when it was so cold, it was clear and it was beautiful viewing, but it was very hard to stay out for more than a few minutes.
Yes, we got a lot of sort of communication errors due to the cold actually at the observatory on the clear nights. We have to do things like voltage override the telescope shutters.
Mhm.
The extreme cold causes some problems. The clouds are probably a bigger one though.
Yeah.
Of course, we've got clouds over the observatory at the moment. So if people are watching live, there's some beautiful stock footage that has been taken on clear nights that our crew will be sharing with everyone. If it does miraculously clear, we might try to open, but I don't think that's going to happen tonight. Fingers and toes crossed for the rest of the week, I suppose. It should be getting a little bit warmer, I think.
Yeah, they're calling for warmer weather, but rain, unfortunately.
Yes.
Not a good time of year for observing usually.
This is true. It takes a lot of perseverance, which is actually a small spoiler for one of our little This Week in Space and Astronomy history items. All right, so getting us started with the show tonight, we're going to do a couple different news items. Before we get started, we always like to start this show with a little bit of interesting This Week in Space and Astronomy history. And of course, this week being January 22nd, and I just have to look at it, 2024. I just like, how does it keep getting so into the future? We're living in 2024. Crazy. But if I go back in time, all the way back to 1979, the 21st of January was a really interesting time in the solar system, actually. And this is just a really fun This Week in Space and Astronomy history because on the 21st of January, 1979, Neptune became the furthest planet in the solar system. And this is very significant if you remember that at the time, Pluto was still a planet. So, um, Pluto is actually considered a planet by quite a few people still. It was officially and very controversially demoted, but in 1979, it was definitely still considered a planet by everyone. And it's thought Pluto is the outermost. Pluto's farther away from the other planets, but its orbit is nowhere near as circular as things like Neptune, Uranus, Jupiter, Earth, for example. And in 1979, Neptune actually moves outside of Pluto's orbit, which means technically and factually, measurably, Neptune was farther away from the sun than Pluto. And this is mostly due to Pluto's strange orbit. So it's got a what's called ellipticity to it. So it's not a circle. It's sort of if you take a circle and you pull the edges out, it becomes very oval-like. And in astronomy, that's what we call an elliptical orbit. And so Pluto actually goes and crosses where Neptune's orbit is and goes inside of Neptune's orbit for just a little bit of its path, which is really, really interesting. And that led to a 20-year run for Neptune as the outermost planet of the solar system, while Pluto's elliptical orbit carried it in closer to the sun. So if you're good at counting, that's 1979, 89, 99. So it is no longer the case. So now we have Pluto past on the other side of Neptune, farther away from the sun today. But this was a very interesting little piece of astronomy history. And actually, this eccentric orbit and having the period where Pluto came closer to the sun than Neptune and then went back out, this made it basically have a different behavior from the rest of the planets, as noticeably different. And it was one of the reasons why they actually downgraded Pluto's status to dwarf planet in 2006. So 2006. Um, its orbit is elliptical, and its orbital plane is also not quite what the other planets have. So you might have heard of the path of the ecliptic, or if you're a stargazer, you might have gone outside to look at the planets or the moon going across the sky. And all of the planets and the sun and the moon all appear to travel along the same line in our sky because our solar system is actually kind of a plane. It's almost like if you had a plate and you embedded all of the planets in it, they would all be kind of along that same plane, except Pluto, which has a little bit of a different tilt to its orbit. So again, it made it more noticeable, I suppose, that Pluto was different, shall I say, than everyone else. Not necessarily bad different, just maybe not behaving exactly like the other bigger planets. If you are looking forward to Pluto being closer to the sun than Neptune, you will have to wait a very, very long time. So, unless you have a way to hang around until the year 2247, and if you do, let me know because that sounds kind of amazing. 2247 is the next time you'll get a chance to see this particular event. So if you missed it in 1979 through 99, I have some bad news, I suppose. Little bit of fun from our icy outer solar system neighbors. So, Mary, have you ever studied any extremely cold rocks like this?
Well, not really. I still remember though, it was interesting because around in the in the sort of mid to late 90s, the other thing, of course, that popped up, sort of thinking of Pluto, is that one, of course, they discovered objects in the Kuiper belt.
Oh,
Uh,
yes.
that also contributed to Pluto's being downgraded as a planet. So, and it
Yes, other large Pluto type sized objects.
were found out there around then. So, but yeah, it's like I said, I still, a lot of people are sometimes surprised to know that Pluto actually does come in closer than Neptune. I think most people think of it as a planet. It's out there, but when you talk about it coming closer, they actually sort of realize, okay, this is why, one of the, big reasons why, they started looking at it. Is it something other than what we'd call a planet? So
Yeah, exactly. And it is interesting to note as well for our listeners, if you're not kind of familiar with solar system distances, one of the crazy things about the icy outer solar system, which are things like Neptune and Pluto, is just how incredibly cold it gets at that very, very large distance from the sun. They're quite far away, from the sun, and as such, by the time you get out to Pluto or Neptune, depending on which one is closer at that particular time, the sun is basically just a star. It doesn't light up your whole sky at all, and water behaves very, very, very much as a solid, which makes it just a really, really strange and interesting place to investigate. Um, all right, so a little bit of fun for our for our episode tonight. Neptune, temporarily the furthest planet in the solar system, and actually, because we're going to be talking about color later on this episode, I do have to mention to all of our listeners, I don't remember if we talked about this last week, but Neptune is not in reality, it is definitely not dark blue. So if you ever seen a picture with Uranus as light blue and Neptune as dark blue, this was a trick. Basically a trick of processing, of data processing. And very early on, when Voyager 2 flew by, um, we got first images, or only real flyby images from Neptune and from Uranus, and they processed the Neptune images differently so that it appeared on the picture that Neptune was dark blue. And that's a choice that we make in astrophotography. We can choose the levels of the colors to bring out different effects. And those dark blue pictures of Neptune got published and were the main images of Neptune. And usually, like hidden in the caption way down, it would say, this image has been processed, or this is not a true color image. The actual color of Neptune is almost identical to Uranus. They're both a very, very light pastel-y sky blue, um, for true color. So, anyways, a little bit of extra Neptune trivia that we'll link in later when we start talking about colors. Blue is a good color, though. All right, so I have one more little fun one that I think will be a nice way to get us towards some of our news items, and a little bit of an opportunity to talk about um, landers. So the next This Week in Space and Astronomy History that I'm going to cover is actually Mars, which is substantially closer. And if we go to the 25th of January and go back only to 2004, so fairly recently, I suppose, all things considered, The Opportunity rover, or the third rover, landed on Mars. And the Opportunity rover was part of a pair. You had Curiosity and or sorry, yes,
Right.
Opportunity Mars rover, Spirit. To
Go
go,
on.
make sure you get all the names correct.
Yeah.
They do all sound. It has been mentioned they do all sound a bit like My Little Pony names. So, but these rovers were doing amazing, amazing work. So it was Spirit and Opportunity. Spirit touched down on the opposite side of the planet Mars, and these little rovers did amazing, amazing exploration for many, many years. And so this was, I really feel like the Spirit and Opportunity rovers were kind of a good start to what I would say is modern Mars, modern landing, modern Mars exploration, but also a lot of advanced, what I would say, advanced computation, advanced landing techniques. And the mission was, by all accounts, a fabulous success. So, Opportunity in specific of the pair went ahead and actually vastly outstayed its lifetime. It was planned to be there for 92.5 Earth days, and it actually lasted 5,498 Earth days. So it was there working for 15 years. That's pretty darn good if you ask me. So it did quite the trek across Mars. And if you get a chance to check out some of the maps where they show just how much of the Martian surface that has been explored by Opportunity and Spirit together, it's a pretty good trek around several different areas around Endeavour Crater. So you have Endeavour Crater, which is a largish crater across the Martian surface, and this little rover from 2004 all the way to 2018, it got out of its little landing site, went all the way past several different craters, and then started to go around Endeavour Crater by 2018 when it finally, um, uh, you know, finally stopped working, shall I say. Um, it has been a wonderful success, but in 2018 the planetary dust storm, which does happen on Mars, the dust storms are something that we will have to consider and deal with for all future Mars missions, because it tends to block things like solar panels and cause all kinds of trouble. And they were hoping that after the dust storm in 2018, the Opportunity rover would reboot once the dust storm cleared away, but probably there was just too much dust that had accumulated on the panels and no light could get through to the solar panel underneath. It could have been something else, but those dust storms are pretty severe. They actually were looking for windy periods to hope that maybe a windstorm might blow enough dust on that the rover would come back, but it didn't. And they did send about 1,000 signals to try to reach the rover to see if it would come back. And I don't know that they're currently sending any signals anymore, but it has fully stopped replying. But given that it went many, many, many thousands of days past its expected duration, I think that this particular rover was a great success. And actually, Spirit did very well as well. So just as a little comparison, the Spirit rover was mated about 2,000 days or so. So it didn't get quite as much lifetime extra as Opportunity, but still many thousands of days more than 90 days. And of course, I have to say the geology exploration in of Mars by Spirit and Opportunity was pretty amazing. The famous blueberries, and you probably know more about this than I do, Mary. The
Yeah.
uh, the hematite blueberries. Formed in acidic water, right?
Yeah. So like I said, it's a very specific kind of chemistry, but it proves there had to be liquid water because you can only form these in liquid water. I mean, there were some other interesting ones too. I mean, talking about spirit, um, the one time they got trapped in the sand, one of the accidental findings is they found sort of caked silicate type material that's associated with volcanic action. So, like the geology that came out of these was quite spectacular and gave us an awful lot of evidence that yes, it actually been liquid water at the surface, and a number of other sort of things like the hot spring evidence that sort of spirit found accidentally when it got trapped in the sand. Kind
Yeah,
of
I remember reading about
spinning
that.
the wheel.
Its wheel was damaged, right?
Yeah.
Yeah,
So
and so it was dragging a wheel behind it, and wasn't the dragging kind of what helped?
yeah, because as it dragged through the sand, it kind of it exposed some of this sort of, I guess, crusted material, you might call it, that was evidence of kind of volcanic springs type activity. So it was quite interesting.
Yeah, and it's it just goes to show that it's definitely you never know what you're gonna find until you get there, sort of thing.
Oh yeah.
And the proof of liquid water on Mars was kind of a big deal because before Spirit and Opportunity, there was a lot of debate, but very little really solid, like it must be liquid water that created this, no argument. So that I think that Spirit and Opportunity can definitely take credit for that.
Yeah, I mean, I still remember they had a big press conference, and this was within a few weeks of them being operational because the blueberries were fairly early finding.
Yeah.
Well, I think there was some other evidence too, but that was sort of the big thing that happened very early on, that they found this that conclusively proved liquid water. I mean, you still remember they had quite a big press conference over it. I know maybe not something someone who's not, interested in sort of the Martian geology would really have paid attention to, but it was quite a thing at the time. Now we kind of take it for granted. Yeah, there was water on Mars, but that was really kind of a turning point, I think, in our understanding of Mars too. That I don't think 20 years later you may not appreciate it, but it's like wow.
Yeah, well, knowing that there is, there was water and there is current subsurface water, and I mean, we're still seeing new little geysers and activity from things like the HiRISE camera,
Yeah,
which is currently in orbit around Mars, looking at the surface. Um, but yeah, I think that this mission in particular with the twin rovers, the fact that the durability went so far over, it let them just explore way larger swaths of the area than they were hoping for originally.
well, it gave them a lot of, I think, direction in the later development of like curiosity and perseverance, simply because of both the successes and failures and problems and everything. It really, although it was funny because I remember several years ago I was at a conference down in the US, the Geological Society of America, and one of the guys talking was one of the chief engineers in the Curiosity project, and he was complaining about the wheels on Curiosity because it'd gone with some high
Yeah.
aircraft material, and it turned out this stuff did not handle the cold on Mars very well, so their wheels were
Yeah,
falling
yeah.
apart much faster than they had anticipated. So, but it's like you said, it's learning like that, and then your next one you design the wheels differently because like, no, this was not a good choice.
Yeah, exactly. Well, that's I think as well it's worth pointing out that this dual mission, this is I think one of the last missions where they touched down with the airbag method.
Yeah,
So basically they had a cluster of airbags that deploy around the craft and it literally bounces along the surface. And so it hits the surface and it goes boing, 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 and it bounces like 30 times before coming to a stop. And so you're literally putting this precious, precious lander inside a giant, very sturdy, but still bouncy ball and bouncing it along a super rocky surface, hoping it doesn't like go into a hole or something. And that method of landing was that was how we did it before we had things like the sky crane,
Yeah.
which was what came next, right?
Yeah, that was curiosity. And I mean, at the time, the sky crane, they're thinking this is kind of a risk, and is this going to work? Because you had three successful landings with the airbags, because of course you had the earlier one, oh, I'm brain freezing on it. A couple of years before Spirit and Opportunity was the first one to do it with Sojourner. Why I can remember the little name of the rover, and now I'm drawing a blank on the. It's the Carl Sagan station now. And then you had Spirit and Opportunity used it, and then with Curiosity decided to try the Sky Crane. So it's like, well, the airbags work, but the airbags had their problems, because I remember with one, I can't remember which one it was, one of the three, or maybe more than one. When they opened the pedals, the airbag was kind of in the way, so they had to
Yeah,
deal with
maybe
that.
it was that Sojourner.
I think it was Sojourner that had trouble getting off at first, because the airbag hadn't deflated quite the way they anticipated, so they had to like jiggle it around to get it actually off of the main craft.
Yeah, but there were, as you say, there were some mishaps, shall we say, and for quite a while. I mean, going into space and having a mission, there were a lot more failures than successes for a long time. If you go back and look at Mars exploration logs, you go back to the early days of the 60s and 70s and 80s. You have things like the was it the Mars Observer was 1992 lost before it
Yeah,
even got there.
yeah.
They had a Phobos orbiter around in the late 80s that was just lost en route. They had another Phobos orbiter from Russia that was lost actually near Phobos. It got almost to there. But you just like the list is like fail, 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 fail,
And
success.
like I said, and even in the late '90s, you had the two, the one, the
Yes.
South Pole lander, and then the other
Yes.
orbiter. But yeah, the orbiter was the funny one, because that they figured someone forgot to do a metric to.
Well, and that's yeah, that one was a I was actually we are talking about that a little bit ago, and it's a really interesting one because the error that caused the crash was a conversion from metric to the British system. And the problem was that they had done all these really, really, really sharp cost cutting, and so they didn't have any of the verification or checks that you're supposed to be doing on the missions. And they're kind of trying to get away without doing the triple redundancy that you're kind of supposed to do. And so it's been said that like the real error was in just not actually checking it for problems.
And well, that's the problem with some of the engineering in the U.S., because a lot of the world, everybody in the world uses the metric system for science and that kind of stuff, and yet you'll
Yeah.
have systems that'll have these kind of, because you're in the U.S., you'll have these systems that are still in you know, the pound feet, all that kind of stuff, and you're like, oh boy.
Yeah, yeah, exactly. It's a constant battle, really. Anyhow, I think I'll go ahead and give some extra props to the Opportunity rover. Landed on Mars almost this day in history, January 25th, 2004. Um, Great success, and of course, lets us talk a little bit about geology, which is also fun. All right, so let's go ahead and do a couple halfway reminders. We do have a couple observatory reminders for our listeners, just as a little weekly roundup. The Allan Carswell Observatory in-person tours have started up again. So in case you missed the announcement, every Wednesday that's not a holiday, we are running in-person tours after sunset. So that means that this Wednesday, which is January 24th, the tour will start at 5 p.m. because it's winter and the sun sets so darn early. By the end of this month, January 31st, our tour will be at 5:30 p.m. So please, if you're getting the free tickets, make sure to check the time, the arrival time on the ticket, because it is after sunset. So the start time changes with the sunsets as we go through. All right, so that's our little reminder. Watch this interesting space for future sun solar eclipse events coming up as we get closer and closer to April. But in this month as well, as a little extra reminder, this week, so not in history, but literally happening now, in a couple days, January 25th of this year, 2024, we actually have a lovely full moon coming up. So we have the wolf moon of 2024. This is the first full moon of the year. It's the January full moon. It's thought to be called this because we're in the northern hemisphere, and there are regions of the northern hemisphere, in Europe in particular, where wolves are active during the early parts of the year. It might be just just coincidence. There are lots of other names for this particular full moon. It's a little bit of fun because this is January's full moon. If you go back in history, you actually have this was the moon after Yule, which is an ancient festival that goes back many 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 years, and it's the annual winter solstice festival. So the winter solstice full moon, if you can remember that far back, we were calling it the cold moon. That's the nickname it got. And this moon, our moon after the Yule or after the solstice, is the wolf moon of 2024. And it's a little bit of fun trivia. Um, Wolves actually don't necessarily howl at the moon, just FYI. Make sure that you're not. They howl up to project their voices, and they tend to be active at night. So they're not actually howling at the moon. But it's still a little bit of a little bit of fun trivia. And if you want to catch the technical time in Toronto for the moment of fullness of the moon, it actually is January 25th at 12:54. The times for the exact fullest the moon is going to be will change based on your time zone. So watch out for that if you're outside of the general Eastern time zone. Little bit of fun coming up this week, and it's really great for binoculars or even just naked eye viewing of the sky. Terrible if you want to do imaging of very faint galaxies. So if you're looking to do some astrophotography of extremely faint sources, prepare to be annoyed. If you just want to look up and have a good time, it's highly recommended. The moon is always fun to navigate around. And we will be talking about the moon later anyway. So it's a good chance for everyone to look up at our nearest neighbor and think astronomy thoughts. All right, so let's see here. We're about halfway through, so let's go ahead and remind everybody. Um, Thanks, everyone. You are listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Our website is yorku.ca/science/observatory. You can find out all kinds of fun recordings from old episodes, as well as links to the new ones, OPV details, hopefully everything you want. If you're listening tonight, you have the pleasure of hearing a bit of This week in Space and Astronomy History with Dr. Elena Hyde and Professor Mary Helen Armour. We just got done talking about the moon, actually, which everyone knows about. So let's go ahead and move forward into the news section of today, where we have a whole bunch of really fun articles. Let's see, we've got them roughly in order, but I think we're going to go back and talk about the color one first, because I have our first item for this week in space and astronomy. I talked about Neptune's color being not what you might have seen. And this gets us into a recent science article about the limits of the human eye. And Mary, this is, I think, a great one. Uh, Thanks for finding it.
Yeah, I'm bad. I tend to surf through the BBC and a couple of the others for regular articles. The sort of EOS from the American Geophysical Union actually has a lot of good ones too, and they're often written more for a science interested. I think the Neptune one really struck me because how many times have we shown those pictures of Uranus and Neptune in an astronomy course? And it's like, okay, one looks more blue and one looks more blue-green. And I always kind of thought there's something that didn't quite jive with that because it's supposed to both be methane based. And then you see this article and you're like, yeah, okay, that makes sense. And then they talk about how they just kind of lost track of it. And those images became so famous that nobody ever stopped to think about how they may have been processed in the past. So
Yeah, well, and that's something we try to warn people about often on this show is when you are looking at a picture of an astronomical object, there's a good chance it has been constructed from scientific filters and given artificial colors to enhance those filters. And that means we pick a wavelength range and we say to the computer, 400 to 600 nanometers is green. That's not what humans see.
no.
um, and your eyeballs, depending on your individual color sensitivity, even human to human, our ability to detect blues, greens, yellows, oranges, and reds will change. And so some people might be able to see, green at, 500 to 500 to 550 nanometers. Other people might just see a single color between quote unquote blue and green, which is 480 all the way through 550 nanometers. So the wavelength of light is set. You can measure the exact wavelength of light, but the color that you even perceive could still be different. And the fact that we also have astronomical science filters, which were specifically measuring different wavelengths in, and then we're pasting colors on top of that, it can make it very hard for people to untangle what does this image actually look like. So a true color image is very different from a science processed image.
Oh, yeah. Well, I think a lot of people when they see the Hubble images, they imagine these beautiful colored things, and you
Yeah.
tell them it's like, no, most of those don't actually look that. It looks really spectacular there, but it'd be like a little green blob through the telescope.
Yeah, well, and I mean, what you would actually see with your eyeball if you were there would be totally different.
Yeah,
But that said, what you see with your individual eyeball is also totally different than what I see and
yeah,
what every other human sees. It's just that, on average, most of our blue, green, and yellow and red receptors are in sort of the same spot. We're all looking around 400 to 700 nanometers of wavelength. That's the range that we're sensitive to. So we just can't detect other wavelengths at all. And, the variation in there is tremendous. So color is a really interesting one. And of course, we're talking about blues for Neptune. Colorizing colorizing Neptune to be a rich dark blue certainly helped to bring out the storms that were present on Neptune's surface, right?
Yeah, I mean that's what they were after with that, right? To try and enhance it. Like Uranus didn't seem to have any of that, so they kind of left it, I think, more it's closer to the true color in most of the images. But with Neptune, of course, they enhanced it. And even the later Hubble images, they were doing some of the same thing because you can't see like some Hubble images of Neptune and you still have that dark blue. So it must have just become kind of what they did with it.
Well,
And they,
that yeah, as you say, that color helps to enhance the storms that were there that they wanted to get details on. So by choosing that color, we got to see more structure, but we didn't get to see what's actually there.
yeah.
So we're it's kind of like if you're putting on polarizing glasses to block the glare from the sun. You put on your polarizing glasses, and then all of a sudden, you don't get giant, white blinding lights coming at you from every direction. You've blocked that light. The light's still there. You're no longer seeing what's really there. You're seeing a filtered version of that. And so, obviously wearing sunglasses or filtered polarized lenses is good because because then you can see what you want to see. And I think it's important to note that scientists do the same thing with their images. And I think the recent image from the James Webb Space Telescope of Uranus, that's a great one because it's actually using infrared light, and they've colored it such that the rings show up really well as beautiful, bright, white, glowing rings, which is absolutely not what you would see if you were there either, in
But like
multiple
I said,
ways.
some of my master's work was on planetary nebula, and even like you see them like the Ring Nebula always have the spectacular red and everything else, and then you have to tell people, but yeah, if you actually look at them, they're just all kind of green. But
Yeah,
it's not
yeah.
the color for the forbidden oxygen line. So if you look at it, that green so dominates. That's what most of them are just going to look like, is a greenish blob. But when you look at the Hubble images and you have like the reds and the blues and the yellows, it's like, no, well, they kind of filtered that and to, enhance different features, but that's not what they actually look like.
Yeah, well, a lot of times in science images, this will go well outside of the wavelength range that you would be able to see at all.
Yeah.
So it's worth noting if you're not familiar with light, light extends well past what we can see. And so what we call radiation, that's just light that we can't see for the most part. So we talk about ultraviolet radiation or infrared radiation. Those are wavelengths that our eyeballs can't detect, but sometimes we can detect them in other ways. So of course, infrared is often associated with heat sources, and we can feel heat. But we don't have visual receptors for those wavelengths. We literally can't see them. Um, I always like to refer to the movie Predator. So if any Arnold Schwarzenegger fans, Predator 1, they've got the alien has vision that is in the infrared. So he sees heat, and it shows you what they see, what the alien sees in the movie. But you can actually buy for your own eyeballs infrared glasses that will take infrared wavelengths, translate them into visual wavelengths, and then you can see it. So it's kind of a cool idea. The idea that you could see, heat vision basically.
And
Um,
it's interesting because if you look at the limits of the human eye, there are species on Earth that can see into the ultraviolet and some of them down into the infrared. Like a lot of bugs and birds see into the ultraviolet.
oh yeah.
Pigeons apparently have incredible vision. I'm like, I always thought, I wonder if you can. And the thought of a pigeon at a telescope always makes me laugh. I don't know why. Um, they have
Well,
great.
we did have a bird nesting in the 60 at one point, but it was not here for astronomical purposes, and it had to leave.
But like I said, I mean, you look at the limits of human vision, and this is why we get into this false color, so that we can actually sort of see some things the human vision can't see, because we are very restricted, and we're not even particularly sensitive in the blue,
Yeah,
right? So
exactly. Well, and that's and that's an interesting one as well because, your own color sensitivity, most people have uh you know less ability to detect color than they do to detect light, which is why you have color sensing cones and non-color sensing cones in your eyeball. And when it gets really dark, everything kind of goes to black and white, right? Your color sensitivity leaves you, and the light that you can detect is very dim, and your low light vision will be more in a basically black and white mode. But yeah, our own eyeballs reactions to color is a whole other thing. There's entire studies that have been done showing that if you can pick different colors of wavelengths of light, they can help you be more aware, or it can also fatigue you, cause you eye strain. Don't even get me started on the blue headlights. Those are the worst. Um, Blue headlights for cars ought to be illegal. Anyway, that's not astronomy, but that's
it's
just
like
wavelength
pollution.
facts.
It's like pollution.
It is light pollution. And that's one of the things that will happen is the blue light will sort of trigger your eyes to go into color mode. You'll lose your nighttime sensitivity, and you are actually at a hazard for driving, as well as, animals, bugs, birds, butterflies, all get their natural rhythms disrupted by artificial light sources, especially at night. So it's yeah, light and color are hugely important, actually much more important than you think. And this is also why all the lights in the observatory, or at least all the ones I could cover, are red, because your eye will not react as strongly to red light. So if you're trying to dark adapt your eyes to get your night vision to work well, having a red flashlight or a red light instead of a white or a yellow or a blue light will actually help you a lot. So it won't shock your eyes, it won't fatigue your eyes like blue light will.
So I also remember like doing photography years ago. I mean, of course, then you used film in a dark room. You only had like dim red lights, because the red light
Yes.
is so much lower energy that you could expose your film or plates. I have actually done plate photography.
We actually still have some photographic plates from the observatory. Obviously, we don't do photographic plates anymore, but that was how it used to be done, even on our telescopes. Anyways, photographic plates notwithstanding. Now everyone's been warned about color, and of course Neptune. So thank you for finding that one. All right, so let's go ahead and talk about the moon, because this is really cool. We talked about, so, this is a great time to look at the moon and think about, would you want to live there? So as I mentioned, the wolf moon's coming up. The moon's going to be full on January 25th, and there are a lot of people very interested in going to the moon. And they recently, actually, there have been a few missions happening, quite recently, where people have attempted to land on the moon. We had a notable failure of the company that was trying to take human remains to the moon, and a notable qualified success of JAXA, the Japanese Space Agency, who recently landed the SLIM lander. And that was as I say, qualified success. This is one that also has a lot of really cool technology hook-ins. We talked about Mars earlier and the Opportunity rover and how it had to bounce around the surface. And Curiosity got to be kind of the first sky crane. Well, this little lander is called SLIM, for Smart Lander for Investigating the Moon. And this one used a very similar but much more advanced kind of jets technology to softly land on the moon. And it makes Japan the fifth country to actually put a spacecraft on the moon successfully. Um, it's a fun little mission. It landed very, very recently. So this was only January 19th. So mere days ago. 10:20 a.m. Eastern Time, and it landed on the moon, but its solar panels were not able to generate electricity because possibly they were angled wrong, is what they're thinking. It actually had just battery power. So it only lasted for a few hours, but they were able to determine that they had in fact succeeded and landed where they wanted to land. So the point of this spacecraft was not just to land and do some experiments, but to actually try a whole new method of landing. This is what they call pinpoint landing, small scale mission. So they had landing radar, they had a laser rangefinder, they had navigation cameras, they had all kinds of cool stuff. And they landed in the area of the Sea of Nectar near the Scioli crater. And the Scioli crater has a slope of about 15 degrees. And they were trying to land in a reasonably small area. They were trying to land in only a 100 meters from a set target point. Other recent moon missions, their landing circle where they were aiming for, the aiming circle was literally 10 kilometers or 10,000 meters. That's the circle they needed to land their craft because it wasn't accurate. This one, 100 meters. So small you could easily walk it. It's a whole new ball game because now you have accuracy, and if you compare this incredible accuracy with the mission we talked about before for Mars, bouncing 30 times across, the rocks, huge, huge difference. And so this little craft also had, a set of jets that were helping to provide a controlled accurate descent. And it was fairly small, so it's not shoebox satellite, so it's still 200 kilograms and around 1.5 by 1.5 by 2 meters, so sort of smaller than a 2-meter cube. And it only cost 121 million US dollars, or 18
That's
billion yen.
that's cheap by mission standards.
Yes, this is very cheap by mission standards, incredibly accurate. Um, and of course, reasonably small compared to other crafts. And the so far, at least they have succeeded in getting there. It's just that they landed with a different angle than they were planning on. And what they're going to do is they're going to actually just wait while the moon slowly spins until the angle changes and the sun hits the panels, and see if they can get contact. And they were actually saying, as of yesterday, they think they might get the angle to go the right way in the next couple days.
Yeah, I mean, it'd be neat. I mean, if you think about a landing ellipse that's that small, I mean, if you look at some of them from previous missions,
Oh yeah.
you're talking like tens of kilometers long, and it makes it very challenging to land because you have to find something that's fairly flat. I mean, imagine trying to find a piece of ground on Earth that's like 60 kilometers long and reasonably flat to land on. I mean, yeah, there's places in the Arizona desert and stuff like that where you could do it, but
Yeah, the salt flats of
salt spots. I mean,
yeah, no.
that's always been part of the missions on Mars as well. We know what we want to land near, but now we have to find a landing site.
Yeah, and then,
Close
hope you
enough.
don't
Yeah.
bounce into a crater. But yeah, this one I should mention as well. It gets us to our next, our sort of our last article. One of the points of having missions that are less expensive and are very, very accurate is you could send them to places on the moon that are thought to have water, oxygen, fuel, helium-3, whatever thing you want to go to. You could actually get there with this. You wouldn't be like, 10 kilometers away, you would actually be in the right spot. So you could just land there, do your experiments, and then success. So it's very important to have crafts like this if you're serious about setting up permanent locations on the moon.
Yeah, it's like I said, I don't think people, when they look at things like the Mars landings, realize just how sort of big a target area
Yeah.
we're landing on. And yet, if you want to build bases and habitation, whether it's permanent or even temporary, you're probably going to be looking to land at some fairly specific spots, like you said, where you can access water or helium-3 or whatever it happens to be that you're particularly interested in. I don't want to land 20 kilometers away and then, okay, it's a long
Yeah, well,
walk.
that's
Well,
exactly, because if you're trying to set up a base on for example, the moon, which people are seriously considering, uh, picking specific locations, like places that actually have some amount of natural radiation shields, and that gets us to the other article you found, Mary, the deep craters or potentially caves,
yeah.
actually putting cave dwellings on the moon, which is kind of what you need for Mars as well. So
Yeah, I mean, there are what they think are sort of lava tubes that are open to the surface, which would make the perfect sort of pre-existing cave that you could build bases into without really having to do a lot of digging and to sort of seal them off would be technically less challenging. And then you have natural radiation shielding, because especially it's not as bad on Mars because Mars does have some atmosphere, but on the lunar surface, when you're in full sunlight, there's nothing.
yeah.
Have no protection. There's no magnetic field and there's no atmosphere. So the amount of radiation they could potentially be exposed to is a big concern, right? If you
Yeah, and I
want,
mean it's been a while since we sent astronauts to the moon, and even then they didn't stay there for extremely long periods of time. They did their moon trip and they came back. So if you were building a base, it would be even more important to have some kind of radiation shielding. The Earth is amazing because we have this totally great atmosphere and magnetic field protecting us. The moon and Mars do not have those. Like Mars has a little bit, but the moon really, really does not.
if you look at the old lunar pictures, you'll notice it's always dark because they were landing when you were away from full sun. And
Yeah.
a big part of that was the radiation issue. They just did not know, what potentially damage could be done if you were standing out in sort of full sunlight with,
Yeah, and that's to say nothing of when the sun is active.
yeah,
So our sun goes through the solar cycle. Currently, we're in an active period. We're getting more aurora, more northern lights because our beautiful magnetic field is protecting us. But the moon is getting blasted by
yeah,
huge amounts of radiation. I think one of your articles said the 1989 blast of solar high energy particles was 8 times the radiation received by plant workers during Chernobyl.
yeah. I mean, it's the amount of radiation you can get hit with is quite spectacular. And the thing is, it hasn't been an issue for the last decade or so because we went into a real solar quiet
Yeah.
period. So, it kind of, I think, fell to the back of everybody's minds, but the solar cycle is becoming more active. We seem to be coming out of that lull,
Yeah,
which
well it's an
more
11-year cycle, so every time it comes around, you're going to get a peak. And when it's at its peak, you're going to get a lot of radiation, and that's a big thick layer of rock is one of the protections we know will work.
yeah, because I don't think you want to be taking as much concrete and lead as you'd need to protect yourself.
Oh yeah, well, and I mean,
And
there
just
are
to get the,
technologies that are proposing, like, could you build bricks out of could you send a lander to the moon and build bricks out of moon soil? But that would just be really, really hard. It would be a lot easier to use an existing cave. Um,
it's like I said, solar activity, it changes so much, even from like solar cycle to solar cycle, right? In the 1950s
Yes.
and stuff, you had a lot more highs, and then sort of early 2000s through the 2000s, even the solar cycle peak was really low compared to previous cycles. So you don't know. And if you get
Yeah, and you could always get
there,
A Carrington event and just
yeah,
be you know, absolutely blasted.
yeah,
But yeah, it's on Earth, it's not going to make much of a difference for us, but it's absolutely deadly if you get caught in something like that on a surface like the moon, which has no protection.
yeah,
So yeah, I know that there are some lists of craters we could probably run by, but I don't think we'll have quite enough time today. But if folks are interested, you can search for skylights on the moon, which are these craters and lava tube entrances that have been found that already exist on the moon. And if you look at the size of those, you will understand why we're so interested in pinpoint accurate landing.
yeah,
Because if you were to try to land in one of those to investigate it before you sent humans there, for example, you would need to be very accurate.
yeah. I mean, even if you were to land just on the outside and sort of crawl down the side somehow,
Yes, exactly.
Melinda, you still need to be near to them. You don't want to land 30 kilometers away, because it takes a rover a long time to travel 30 kilometers. It's not,
Yes, they are slow moving,
they're slow moving. So
slow moving vehicles.
if you can land like 50 meters away, it's not a problem. You don't want to land 5 kilometers away.
Yes, exactly. All right. Well, I hope we've convinced everyone that the moon is a fun, if slightly dangerous place to hang out. It is about time to wrap up for tonight. So thank you everyone for joining us. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Professor Mary Helen Armour and myself, Dr. Elena Hyde. You can always connect with us on Twitter with the York Universe, Instagram, or of course Facebook at Allan Carswell Obs. Check our website for any show notes, content updates, and contact info, yorku.ca/science/observatory. Thanks for tuning in to York Universe, everyone. Clear skies and have a good night.